worth up to 10 lakh rupees. His professional affiliations are equally impressive. He is a member of AEEE, ACM, ISTE, CSI, and other several international organizations. He also serves on the editorial boards and review panels of reputed journals, including Spring Nature and the World Journal of Engineering. In recognition of his outstanding contributions, Dr. Asadi has received numerous national and international awards. These include the Bharat Vidya Ratna Award from the International Business Council, Delhi, the Best IT Teacher of the Year Award in 2020 from ITAP and Tutors Pride, Hyderabad, the Lifetime Achievement Excellence Award in 2022, and an Outstanding Teacher Award in 2022 from the Research India Foundation. Most recently, he was honored with the Best Academic and Research Guide Award in March 2025 for his exceptional mentorship in artificial intelligence and data science. Dr. Asadi technical expertise covers a wide range of fields, from data science, big data analytics, and machine learning to robotic process automation, cloud computing, and artificial intelligence. He also holds more than 30 professional certifications, including IBM, Microsoft, NPTLE, and IIT Bombay programs. Having traveled to countries such as Malaysia, Singapore, Kenya, Ghana, Ethiopia, Dubai, Bangladesh, and Australia, Dr. Asadi continues to make a global impact through his collaborations, workshops, and research initiatives. Truly, Dr. Asadi Srinivasulu embodies the spirit of lifelong learning, research excellence, and academic leadership. So I would just like to Dr. Asadi Srinivasulu to take over the session and deliver his thoughts on AI-driven data analytics from insights to smarter decisions. So please continue our session. Thank you.
Yeah, thank you for a nice introduction. A warm welcome to a 6-day AICT FDP on. Today's topic is artificial intelligence driven data analytics from insights to smarter decisions. Let me justify my title first. So, in order to generate interested data analytics, insights from the huge volume of data, and extracting meaningful interested patterns from the large volume of data by applying statistical, artificial intelligence, machine and deep learning techniques. So from insights, we are taking better decisions and smarter decisions on societal applications like healthcare data analytics, weather forecasting, stock market analysis, traffic road data analytics, educational data analytics, whatnot. Wherever data is there, we are generating interested analytics. From there, we are using big data technologies like Hadoop and Spark, and we are using latest technologies of artificial intelligence extension is generative AI, agentic AI, explainable AI, transfer learning, and federated learning, etc. So this is today's concept, and this is a forthcoming workshop. Ma'am, can you record the session? Ma'am, please record the session.
Sir, it's recording, sir.
Sir, it's
Yeah,
recording.
thank you so much. Yeah, thank you so much for acknowledging. And this is a workshop we are organizing from University of Newcastle at Australia in the Department of CRC Care. And the topic is AI-driven data analytics from insights to smarter decisions. So if you go to this URL, you come to know. So she explained my background. So one PhD in data science from JNTU and another PhD from artificial intelligence at the IIIT Allahabad. Some disturbance is coming. Mute yourself. Yeah. So this is my background, and these are my research interest. Right now, I'm doing on Australian groundwater data analytics by using statistical, artificial intelligence, machine, and deep learning techniques. My interested areas are generative AI, agentic AI, federated learning, explainable AI, transfer learning, machine and deep learning, data science, cyber security, health data analytics, and so on. And these are my publications. Right now, 200 plus publications are available in the IEEE Explorer, Scopus, Web of Science, and Science Citation Index. And remaining papers are in a UGC listed. I have a YouTube channel I have created last 2 years back. If you click this URL, there are 100 participants are there. You just take your mobile and go to your YouTube channel, type Dr. Asadi. You will get my channel, Dr. Asadi Srinivasulu, and nearly 500 videos and 3.54K subscribers are available right now. These are my latest uh, videos on different technologies like artificial intelligence, big data technologies, generative AI, and Internet of Things, blockchain technology, whatnot. So many technologies I have explained. And I'm a corporate trainer on data science applications using AI, ML, and DL techniques. And everybody knows data science. Data science is the process of extracting meaningful, interested patterns from the huge volume of data, extracting insights from the large amount of data by applying statistical, AI, machine, and deep learning techniques. And I'm a corporate trainer on generative AI applications using ML and DL techniques. What is meant by generative AI? Generative AI is an extension of artificial intelligence. Generative AI is nothing but creating a new application, innovative application, which is new and which is not available in the existing database. And by using generative adversarial networks and variational autoencoders on audio, video, text, graphics, animation kinds of applications we are developing with the help of generative AI. Right now, I am taking for US and Canada students corporate training on generative AI applications using ML and DL techniques. So this is the syllabus of generative AI. 13 core subjects and followed by the four major case studies. I'm a corporate trainer on cyber security applications using ML and DL techniques. So, in order to prevent and predict and detect cyber attacks, cyber criminal activities by using the latest technologies of artificial intelligence, and this is the syllabus of cyber security. There are 13 core concepts and followed by the list of projects. And I'm a corporate trainer on data science applications using AI, ML, and DL techniques. This is the syllabus of data science training. And within 60 seconds, what will happen? How many users are connected to the internet world? And what is internet? Internet is a network of networks. What is network? Interconnection between the computers in the fashion of local area network, wide area network, metropolitan area network, etc. Internet is developed by Bold, Berneck, Newman. Three scientists has been proposed. Within 60 seconds, how many users are connected? See, 2.4 million Google searches happened within 60 seconds. 11,035 fake accounts removed within 60 seconds. And 10.4 million viewing minutes happening in the Instagram. 6 lakhs 94,000 video was viewed. So many activities happening in these 60 seconds. Where the data is coming from, how many servers are required to store a huge volume of data. That's why we are going to utilize cloud computing concept. What is meant by cloud computing? Cloud computing is a internet based technology. Without internet we cannot perform any service based kind of application. That's why cloud computing is a pay and use. So cloud computing backbone is data center and virtualization. What is meant by data center? Data center is a collection of high integrated servers at one place, just like a football court, such a height buildings of data centers. Each company having their own data centers. And one more backbone is virtualization. Virtualization is the ability to perform multiple tasks in a single system with help of virtualization technologies like VMware, Hypervisor, Zen, Virtual Iron. These are the popular virtualization technologies. So why I am explaining? Wherever data is there, there is a data security problem. There we are performing data science insights, we are extracting, we are generating interested data analytics. So where we are getting huge volume of data from banking services, banking sectors, weather forecasting, NASA data, stock market data, traffic data analytics, educational data, whatnot. So many resources. So the see, if you click this URL, we are getting a huge volume of data from various sources. See here, uh, how many users are connected to this internet world. Can you see the number? Number is changing drastically here. Can anybody read this number? Very interesting question. See, very huge volume of number. That means how many users are connected to this internet world, how many births today, and how many births in this year, deaths in the today, deaths in this year, population growth, everything. See, the internet live statistics, India is the number one country, China followed by USA, Indonesia, Pakistan, Nigeria, Brazil, Bangladesh, Russia, Ethiopia. So this is the way we can find out the growth rate, past, present, and future, and the growth rate of this internet users. So many things we can see the internet live statistics. Okay, so now see, I'm moving to internetlivestats.com. How many internet users are connected in this world? Total number of websites opened, emails sent today, Google searches today, blog post written today, tweets sent today. If you click this URL, so we come to know that these statistics. Keep in mind. So same thing I have incorporated in this slide. Number of users are increasing automatically. The size of the data center also increases. If you click this URL, you come to know how many users are connected this internet world. Then if you press capital A in the system, system cannot understand capital A because internally it converts into ASCII value. What is ASCII? American Standard Code for Information Interchange. There is a standard keyboard. How many keys are presented? 107 or 108 keys are presented in the standard keyboard. Each key having its own ASCII value. If you press capital A, system cannot understand. Internally, it converts into ASCII value. The ASCII value for capital A is 65. If you divide it by 2, we are getting binary equivalent number is 10001. That means computer understands only ones and zeros. 1 bit is equal to 0 or 1. 4 bits is equal to 1 nibble. 8 bits is equal to 1 byte. 4 bytes equal to 1 word. 4 words equal to 1024 bytes. 1024 bytes equal to 1 kilobytes. After that, megabytes, gigabytes, terabytes, petabytes, hexabytes, octabytes, zettabyte. Hi, I am Robo. My speed is 1 terabytes. My memory is 1 zettabyte. Thanks to director Shankar and Rajnikant sir, they have introduced that terminology in the Robo movie. But as a technical person, we know. But the latest terminology is presented or not. Yesterday night, again I searched in the Google. I got it two more terminology. 1024 zettabyte is one yottabyte. 1024 yottabyte is one brontobyte. 1024 brontobyte is one geobyte. 1024 geobyte is infinity. So same measurement if you do in mathematical, there are two types like normal range and big data range. Kilobyte is 10 power 3, megabyte is 10 power 6, gigabyte is 10 power 9, terabyte is 10 power 12. And petabyte is 10 power 15, hexabyte is 10 power 18, zettabyte is 10 power 21, yottabyte is 10 power 24, brontobyte is 10 power 27, geobyte is 10 power 30. This is the way we are measuring the huge volume of data in a computer servers and data center. So this is the syllabus of data science training. I don't want to explain all these things. Just you can check. This is the syllabus of introduction to data science. In order to implement data analytics or any data science applications, we are using Python programming. So 1 to 11 is a core Python programming, and the 12th one is advanced Python programming in order to solve artificial intelligence, big data, machine and deep learning, cyber security, data science applications. We are using these advanced Python programming libraries like NumPy, SciPy, Panda, Scikit-learn, Matplotlib, sklearn, Scikit-learn, Theano, TensorFlow, Keras, Pillow, and PyTorch, etc. So these are the top 10 libraries I am using regular and every day in order to implement any sort of latest research applications. NumPy, Pandas, Matplotlib, Request, SciPy, Scikit-learn, TensorFlow, Keras, Beautiful Soup, Flask, Django, etc. So Python for everything, whatever, irrespective of the domain, we are solving the application with help of libraries. So this is Python roadmap, and this is the syllabus of statistics is required for in order to implement data analytics of artificial intelligence applications. Then data structures and algorithms is a core subject. In order to write efficient program within few steps we are implementing, and efficient algorithm we are writing based on the data structures approaches like divide and conquer approach, dynamic programming, greedy approach, branch and bound, etc. Then database management and warehousing. In order to store a huge volume of data, we are using two types of DBMS languages like relational databases and non-relational databases. Relational database languages called based on the syntax, based on the relation table schema. We are creating the table. Table is nothing but collection of rows and columns. Collection of tables is called a database, and with the help of relational database languages like SQL, MySQL, Teradata, DB2, MS Access, etc. And non-relational databases like there is no schema, there is no relation, there is no procedure, but I would like to create a table of data, a database with help of unstructured data like audio, video, text, graphics, animation, with the help of Mongo database, Hive database, HBase database, Zookeeper, Woozy, Cassandra, etc. And artificial intelligence is nothing but intelligent behavior in a machine to solve complex applications, science and engineering, to develop intelligent kind of based applications by using statistical, AI, machine and deep learning techniques. These are the top 10 concepts of artificial intelligence. And generative AI is nothing but generating a new something innovative application which is not available in the existing database with the help of generative adversarial networks and variational autoencoders on audio, video, text, graphics, animation kinds of applications with the help of generative AI techniques like GANs, VAE, autoregressive models, transformers, deep generative models, etc. The data mining is the process of extracting meaningful, interested patterns from the huge volume of data by applying classification techniques, clustering techniques, association rule mining techniques, outlier detection, recommender engine, etc. Natural language processing is nothing but study of different languages, study of linguistics by applying various NLP techniques like pause, parts of speech, text processing, tokenization, syntax and parsing techniques, and tagging and named entity, word embeddings, vector representation, language modeling, sentiment analysis, machine translation, and transformers and large language models like ChatGPT, DeepSeek, GenAI, Claude, Gemini, etc. And big data analytics like which data we can call it as a big data. Traditional systems are unable to process the data, load the data, to perform the data. uh, that's why such type of data is called big data. Maybe terabytes, petabytes, exabytes, octabytes, yottabytes, zettabytes. That's why we are using big data technologies like Hadoop and Spark. So Hadoop, based on the Java programming, we have two important major concepts like HDFS, Hadoop Distributed File System, and MapReduce is a programming model based on the Java. We are executing, compiling, and finally deploying the application. If you are using Scala programming, go with the Spark technology. Okay, so this is there are various tools are available in big data technologies. Then artificial neural networks is a base concept for machine and deep learning techniques. And we are how our brain consists of number of neurons are working the functionality of the brain. Same way we are creating artificial neurons, that is called ANN. The extension of ANN is machine learning, deep learning, and etc. Then machine learning is nothing but learning from the observational data by applying supervised learning, unsupervised learning, and reinforcement learning, and various techniques we are solving the applications. Then the extension of machine learning is a deep learning, learning from the observational data with deep manner by increasing number of input layers and increasing number of hidden layers and fine tuning parameters and dropout function, activation functions like ReLU, softmax, etc. And major techniques of deep learning is CNN, RNN, LSTM, etc. CNN is nothing but a convolutional neural networks. RNN is nothing but recurrent neural networks. LSTM is nothing but long short-term memory, etc. And the last today's concept is augmented reality and virtual reality. It comes under artificial intelligence. And in order to solve audio, video, text, graphics, animation kinds of applications, we are using this AR, VR techniques and tools and technologies. So these are the major projects under my artificial intelligence and data science research laboratory. So far, I have executed nearly 153 projects with help of my PhD and Master of Technology students. So these are the 153 projects. And today's very interesting data analytics of artificial intelligence application is very interesting application. See, now I am going to demonstrate. What is your date of birth? If I am asking the question, immediately you are saying 15th July 1978. Okay. So when is your death date? See, sir, what is this question you are asking? That means, so there is a model. That model is nothing but simplified version of the reality. So life to vector is a model. it can solve such type of death date application, lifespan of the human being. It utilizes advanced natural language processing techniques, machine learning techniques, and deep learning techniques we are using in this application life to vector model. So there are input parameters we are taking like biological data, lifestyle factors, data of birth, height, weight, cholesterol, body mass index, everything we are taking as an input, and we are expecting lifespan of a number of years of human being. Recently, I have checked with my input parameters with this program. Write a Python program to simulate to find out a death date of a person by utilizing number of input parameters, and let me execute this program. See here, just to go to command prompt. I think everybody knows Python programming. If you don't know, it is not a problem. It takes 2 minutes to install Python. Just go to Google, type Python software. You will get 35 MB file. Download it, double click it, and install in your system. Once completed, you type like this: Python, which version you have installed, Python 3.13.7. So Python is a scripting programming language. Python is an object oriented programming language. Python is an interpreted language. Python is developed by Guido van Rossum from Netherlands. He is a great fanatic of circus game. In that circus game show, there is a snake is ongoing in that circus. So you got an idea, why don't I can avoid the drawbacks of C and C++ programming languages? Why don't I can give name as a Python for this language? So Python can be executed in two ways. One is IDLE. This is called IDLE. So integration development life cycle, integration development learning environment. So simple program, write a Python program to perform addition of two numbers. Very simple program. For your understanding purpose, I am showing. So a is equal to 3, b is equal to 2, c is equal to a plus b. That means every line it interprets and gives the output. But I don't want this IDLE. I want to use my own program in scripting way. So now I'm clearing the screen, CLS, and a notepad space. I am writing my own program for to find out the death date of a person. So see here, my file name is vet0 dot python. So now my Python program will open in notepad. See here. So this is my Python programming. Write a Python program to find out the death date of a person by using input parameters. I'm declaring libraries like NumPy for numerical, Python for matplotlib for visualization purpose. I'm declaring the adjust function to predict the lifespan, adjust the parameters like sample input I have taken, and see here biodata, gender, blood pressure, body mass index, and cholesterol, exercise, diet, smoking, the habitual actions, exercise, so many parameters. And finally, we are displaying in the bar chart. Now see, I'm executing Python space vet0. Now see, so I'm executing Python programming of my own program. Madam, acknowledge me, my screen is visible or not?
Yes, sir,
Yes,
visible.
sir.
Yeah,
Yes,
thank
sir,
you.
visible, sir.
Yeah, thank you so much for acknowledging. See here, I have taken my own input parameters. The predicted lifespan is 77 years. The actual lifespan is 70. So this is one of the interested uh, application of artificial intelligence by using generative adversarial networks and variational autoencoders. We are solving such type of applications. Okay, so now see, so far we have executed that program. Then see the second program, same program with the healthy person input parameters I have taken. Same, write a Python program by using live to vector. We are finding the lifespan of a person. I'm using libraries like NumPy, Matplotlib, etc. And these are the input parameters I'm taking. Predict the lifespan, plot the plot the prediction, and etc. Now see this program. I have changed the parameters and input parameters, and let me execute this program. Python space. My file name is a lifespan. See here. So this program I'm executing directly. See here, 93 years. This predicted lifespan and actual lifespan is showing more than 99. Based on these parameters, uh, see this is kind of intelligent kind of based application. Likewise, we can execute n number of applications. Okay. Same way, same program, we can see the what are the features are influencing of lifespan of a human being. Risk score, alcohol consumption, smoking history, and body mass index, age, etc. So with this one, fundamentals are closed now. Now I am moving to today's concept with the practical demonstration. This is my channel. Take 1 minute time. Go to YouTube. Type my name, Dr. Asadi. There are 150 members, 150 participants are there. So I'm expecting at least 150, 140 members must subscribe my channel and forward to your friends and relatives and students. This is my sincere request, and it is not for money. It is for my scholars and students, whoever interested, they can listen my videos. Nearly 500 videos are there. So this is very interesting question. Can anyone predict what is this image or diagram? What is the technical name of this image? Can anyone guess the answer? Please type your answer in the chat box. What is this technical image of this image? Technical name of this image. Everything I have incorporated for data analysis, data analytics. The complete process is presented, complete models are presented. Okay, the technical name of this image is word cloud of AI driven data analysis workflow. And see, in order to make intelligent machines, okay, we are how this artificial intelligence and automations are shaping a more efficient, intelligent, and technology driven future by using this. That's why I can give the topic like smarter tomorrow, the rise of intelligent machines. So what is AI or artificial intelligence? Artificial intelligence is the branch of computer science that studies machine intelligence, the science and engineering to develop intelligent kind of based applications by using statistical AI, machine and deep learning techniques. So examples of artificial intelligence applications, search engines like Google, and content recommendations like Netflix, YouTube, self-driving vehicles, automatic language translation, facial recognition, computer spam filters. That's why an AI is a computer system that performs tasks that usually require human intelligence. Ma'am, can you mute them? You can mute them, ma'am. Somebody is hello. Mute yourself.
Yes, sir. Yes, sir. I'll do it.
Somebody is disturbing me.
I'll do it, sir. Sir, is this okay, sir? Hello?
Sir, your voice is not audible, sir.
Sir, your voice is not audible, sir. Sir, please on your mic, sir.
It is unmuted. Okay. Now, my voice is audible right now?
Yes, sir.
Yes, sir.
Yeah. Thank you so much. And artificial intelligence is a computer system that performs tasks that usually require a human intelligence. So, if you want to create any intelligent kind of based applications, so we are integration of robotics and artificial intelligence to create a human-like systems capable of perception, learning, rational thinking, and autonomous decision making, just like a humanoid robots like Asimo, Sophia. Sophia recently took the citizenship of Saudi Arabia. She can dance, she can cook, she can sweep, so many activities, just like humans, human like system. Sophia is performing many multitasking system. Then see the difference major components of artificial intelligence. Machine learning is nothing but learning from the observational data with the help of supervised, unsupervised, and reinforcement learning to recognize the patterns based on algorithms. Neural networks is nothing but it is a computer systems designed to imitate the neurons in a brain. Natural language processing is nothing but study of different languages or a study of linguistics. We can understand and analyze documents. Not only speech, audio, video, text, graphics, any kind of understanding and analyze documents. Robotics, machines that can assist people without actual human involvement. So that's why the evolution and impact of intelligent machines driven artificial intelligence and data science to understand how automation and smart technologies are transforming industries, research, and daily life. That's why this artificial intelligence can be used in AI search engines, robotics, smart manufacturing, healthcare analytics, and intelligent automation systems to build advanced data driven solutions for the future. And AI powered robots, self driving cars, intelligent assistants like ChatGPT, Gemini, Claude, DeepSeek, GenAI, etc., to predictive healthcare systems. So, what are the main parts of artificial intelligence? So, there are many concepts like AI, robotics, machine learning, natural language processing, computer vision means audio, video, text, graphics, animation kinds of applications. Then machine learning and deep learning together enable intelligent systems to learn, perceive, and act autonomously. So, what are the major features of artificial intelligence? We are performing deep learning concepts, facial recognition features, automate tasks, data ingestion, cloud computing, quantum computing, chatbots, etc. And how AI is impacting our lives. See, if you see the smartphones, how it is attracting us. So many activities we are performing, not only audio, video, text, graphics, animation kinds of applications. Security and surveillance, social media platforms like Facebook, Instagram, LinkedIn, etc. Navigation, e-commerce websites like Amazon, Flipkart, etc. Banking and the finance sector, autonomous vehicles, smart home, etc. So that's why, what is the role of intelligent machines or artificial intelligence learning for the successful implementation of business model? If you see the major branches like artificial intelligence, such as machine learning, natural language processing, speech, vision, expert system, planning, and robotics, showing how AI mimics human intelligence to perform complex tasks efficiently. If you see the machine learning, we have a predictive analytics, descriptive analytics, deep learning, then language processing analytics. We have classification, translation, data extraction. In speech, we have text to speech, speech to text. Expert system is nothing but we are developing if then rules and maintaining a huge volume of database. If you are asking any query, my database, intelligent database, is replying whether the query is true or false. Okay, and it can give the certain answer. Then planning and optimization, vision, having image recognition, mission vision, robotics, etc. So why this artificial intelligence is different than agentic AI? It's a latest topic of nowadays. It is a buzzword in the industry. What is the main difference between artificial intelligence and agentic AI? Let me clarify. Artificial intelligence is a subject under computer science engineering. It is a big umbrella. Under that artificial intelligence, we have a number of new concepts like machine learning, deep learning, transfer learning, explainable AI, federated learning, generative AI, agentic AI. Agentic AI is nothing but it is also intelligent behavior in a machine. That machine is works for only autonomous system. It can perform automation task within autonomous nature. So that's why repeated works in the autonomous nature, where it is agentic AI is completely autonomous system, whereas artificial intelligence is different than agentic AI. What are the major benefits of agentic AI? We can optimize the operations by adapting to changing conditions, especially in Amazon e-commerce websites, so many applications, freeing employees from routine tasks, allowing them to focus on higher value tasks, improving efficiency with end-to-end automation for intricate workflows, then integrating with external systems and tools, etc. So, what are the major components of this artificial intelligence? Why it is so rise of intelligent machines right now? Because how artificial intelligence can work with help of machine learning, deep learning, robotics, data analytics collectively drive the creation of smarter applications, interconnected systems shaping the future of technology and society. We have advancements in artificial intelligence are driving rapid innovation. They enable automation across various industries. Examples includes robotics, data analytics, and autonomous vehicles. Intelligent machines are increasingly performing tasks autonomously. That is called an agentic AI. And these are the applications of agentic AI because it can solve autonomous of system with particular task, repeated works, robotics and autonomous vehicles, healthcare system, and finance and shared services, smart cities, customer service, etc. So these are the major 50 topics are there in artificial intelligence. I'm taking as a corporate training or for 50 topics with each topic with the practical demonstration I'm going to show. So this is the origin of artificial intelligence. Mid 20th, it started way back. Okay, 1950s. Turing's impact. Then now 21st century we are using agentic AI, generative AI, explainable AI, federated learning, and we have so many extension of artificial intelligence concepts we are using. That's why how this artificial intelligence playing a vital role in this in this modern era. We are solving so many applications. That's why the ability to learn and understand and deal with a new or trying situation specifically. It is a simulation of human intelligence processed by machines, especially computer systems. These are the 50 steps to learn AI, starting with understanding AI types and definition, and ending with the work on interdisciplinary AI projects. You are ready for industry with help of 50 steps you need to follow. Okay. So in detail, if I go, it takes time. That's why I will share this PPT to you so that you can get a idea on this concept. And see here, and see in this in this artificial intelligence is a big umbrella. Under this, we have so many concepts. So in deep learning, again, we have agentic AI, generative AI, and the neural networks, machine learning. Okay, so many concepts we are using. Okay. So in this artificial intelligence, I am going to demonstrate and explain what is deep learning techniques and what are the neural networks we are using, what are the machine learning concepts and techniques we are using, and how this agentic AI is different than artificial intelligence, and how generative AI applications are innovative right now in the market. So many concepts I am going to demonstrate right now. These are the top 10 AI concepts explained, starting with artificial intelligence and ending with AI ethics. And see the universe of artificial intelligence. We are solving various applications of generative AI, deep learning, neural networks, machine learning, and see, this is a big umbrella. Under that, we can see the various concepts. 20 essential abbreviations to understand AI. So many concepts are there in this artificial intelligence. Okay, so the simulation of human intelligence by software coded industries or heuristics like thumb rule. We are solving so many complex applications. And see here, in this artificial intelligence, we have examples like self-driving cars, security, manufacturing, healthcare, media recommendation, online banking, spam filters, smart assistants, chatbots, etc. So I have already explained the three types of artificial intelligence, and what is the difference between AI, ML, and DL. Intelligent artificial intelligence is nothing but computers that can imitate human intellect and behavior, the science and engineering to solve complex applications by applying statistical AI, machine, and deep learning techniques. Machine learning is nothing but statistical algorithms that enable AI implementation through data, subset of machine learning, which flows neural networking. So AI is the demonstration of human-like cognition or behavioral machines, including perception, computer vision, natural language processing, generalization, memory, reasoning, problem solving, symbolic manipulation, learning from past experience, motion and manipulation, etc. So these are the most frequently used AI technologies today. Image analysis, like COVID-19 prediction detection on chest X-ray images, CT scan images, etc. Virtual assistants like Alexa, Google, and Siri, etc. Predictive analytics, machine learning, natural language processing, self-driving technologies, robotics, etc. And this is the life cycle of artificial intelligence. You can start with autonomous systems, machine learning, deep learning, chatbots, real-time emotion analytics, virtual companions, etc. See, how does artificial intelligence AI work? See here, cognitive computing, computer vision, machine learning, neural networks, deep learning, natural language processing, etc. So these are the 5 steps we are using. Data input, maybe speech, text, image, context, outcomes. Data pre-processing is nothing but eliminating noisy data, inconsistent data, dirty data, etc. Then outcome, success or failure. Adjustments like data, algorithms, outcomes, assessment and analysis, discovery, feedback, etc. So these are the various concepts of artificial intelligence, and where we are using this artificial intelligence: predictive analytics, real-time operations and management, customer services, risk management analytics, customer insights, pricing comparison, promotion, customer experience, supply chain, human resource, fraud detection, and research and development. So, goals of artificial intelligence: we have planning, robotics, machine learning, deep learning, NLP, perception, knowledge, cognitive system. So, these are the major goals: develop a problem solving ability, allow continuous learning, encourage social intelligence, promote creativity, enable human AI synergy, and reasoning, automated learning, scheduling, machine learning, NLP, computer vision, robotics, general intelligence. So these are the basic concepts. I'm skipping because of time. I'm going to demonstrate a few applications. So these features I have explained, and the need for artificial intelligence emphasizes analytical thinking, entertains active learning strategies, increase creativity and originality, induces critical thinking, builds leadership and social influence, interactive reasoning and problem solving, emotional intelligence, and so these are the difference between data science and artificial intelligence. What is the scope of data science? It involves various underlying data operations. In artificial intelligence, the scope is limited to the implementation of machine learning algorithms. Types of data: data science can take structured and unstructured, and artificial intelligence standardized in the form of embeddings and vectors. Tools we are using in data science are Python, SAS, SPSS. So, I mean, a social statistical package for social science, TensorFlow, Keras, Scikit-learn. In artificial intelligence, we are using Scikit-learn, Cafe, PyTorch, TensorFlow, Shogun, Mahout. Applications like data science, advertising, marketing, internet search engines, artificial intelligence, manufacturing, automation, robotics, transport, healthcare, etc. So, in this, see, these are the major concepts I have explained. And see here, what is meant by reinforcement learning? Learning from the observational data based on the punishment and reward. We are solving the applications, especially gaming applications. Computer vision is nothing but we are solving the problems like audio, video, text, graphics, animation kinds of applications. And generative AI adversarial networks is nothing but it uses two neural networks like a generator and a discriminator in a competitive setting. I would like to give one best example of application here in this generative adversarial networks. Uh, how the baby, 1 year baby expressions after 5 years, after 10 years, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60. How facial expressions over the period it changes. Such type of application is developed by one of Japanese scientist, professor. He has created that app right now. All the mobile phones, how you are look like in a baby after 10, 15, like that. We are solving various applications by using generative adversarial networks and variational autoencoders. Okay, so that is the greatness of the generative adversarial networks application, facial expression application we are developing with help of GANs. Transfer learning is nothing but it is extension of machine and deep learning technique, and it improves the efficiency and performance in new domains. Explainable AI is extension of artificial intelligence. This approach aiming to make artificial intelligence systems more transparent and interpretable, enabling humans to understand the reasoning behind AI decisions and prediction. Federated learning is nothing but we are running our application in a decentralized devices, sharing model while keeping data localized, preserving privacy and reducing communication overhead. So now these concepts I have already explained. Such algorithms we are using uninformed search. Here we are using breadth first search and depth first search. It is also called as a blind search. Informed search is also called as A star algorithm and a greedy best first search. Then adversarial search, just now I have explained. In chess gaming applications we are using. Then these are the examples of artificial intelligence, voice assistants like Siri, Alexa, Google Assistant, etc. Recommender system we are using uh, like e-commerce websites, Amazon and Flipkart. Fraud detection, example of artificial intelligence. Autonomous vehicles like self-driving cars, personal assistants like Siri, Amazon Alexa, Google Assistant, chatbots, image recognition, gaming application. So these are the various examples of artificial intelligence. Unnamed drones, self-driving cars, smart assistants, and spam filters, robots, facial recognition, etc. So these are the examples of artificial intelligence I have explained already. And now we will see the some practical demonstrations. What are the major components of AI? Machine learning, I have explained NLP, robotics, computer vision, expert system, neural networks, planning and scheduling, knowledge representation, deep learning, reinforcement learning. These are the major components. Computer vision means audio, video, text, graphics, animation kinds of applications we are developing. Machine learning, neural networks, deep learning, natural language processing, etc. So these are the components and tools. For languages, we are using R programming, Python, C Sharp, Java, Julia. Data platforms like Spark, Hadoop, SQL Server, PostgreSQL, and ML and AI tools like H2O, TensorFlow, XGBoost, data exploration and visualization tools like Veka. You know Veka expansion, Vaikato environment, knowledge for analysis. Veka came from Mecca. Mecca is a flyless bird. It is there in Waikato University at New Zealand. Two professors developed this Veka tool. Data ingestion tools like SQL Server, development tools like R, Jupyter, etc. So these are the key components I have already explained. Concepts also I have explained. Five most important concepts are also I have explained. So directly I'm going to see what are the artificial intelligence techniques are available. Techniques you can consider like machine learning techniques, deep learning techniques, natural language processing techniques, computer vision techniques, robotics, expert systems, reinforcement learning, Bayesian networks, fuzzy logic, genetic algorithm. These are the top 10 algorithms of AI, artificial intelligence. So these are the core technologies I have already explained. And so these are the AI tools. TensorFlow for machine learning purpose, PyTorch for machine learning framework, Keras for big data analytics, machine learning, OpenCV computer vision applications for image processing, H2O for artificial intelligence applications, IBM Watson for natural language processing, Microsoft Cognitive Services, Google Cloud AI, Amazon Web Services, PyBrain, etc. These are the best pack of AI tools. Paid version, free versions. Paid version we have number one OpenAI product is ChatGPT, Midjourney, Fireflies, Runway, Podium AI, Trent AI, Opus Clip, Canva, ChatGPT, Synthesia. Free tools like Claude AI, Bing Create, Lexis, Pika Labs, RECI, Audio Open, 2S Short AI, Microsoft Designer, Bright Sonic Photo. So these are the AI tools and techniques. And what are the advantages? Efficiency, accuracy, speed, consistency, personalization. The differences between pros and cons: increased efficiently, reducing human risk, aid in decision making, availability. The drawbacks of artificial intelligence: cause of unemployment, high initial investment, dependency on machines, lack of creativity. Disadvantages are this one. Then challenges. So these are the challenges: bias and discrimination, data quality and quantity, explainability and transparency, ethics and regulations, and opportunities like improved efficiency in productivity, enhanced decision making, personalization, innovation. Challenges: AI algorithms bias, black box problem, requirements of high computing power, complicated AI integration, and see. So these are the software of artificial intelligence we are using: TensorFlow, Azure Machine Learning, Salesforce, and Asadi, Placement, Cloud Machine Learning, etc. These are the softwares we are using. And these are the applications: healthcare, finance, manufacturing, retail, transportation, education, gaming, agriculture. These are the various applications. And these are the applications. So many applications, benefits. And now see, I'm going to demonstrate some practical applications. Okay. Now see, top 5 AI trends. Computer vision set to grow, boost to autonomous vehicle industry, chatbots and virtual assistant to get smarter, solutions for metaverse, improved language modeling. Best pack I have already explained. And these are the tools: Keras, TensorFlow, PyTorch, Sonnet, MaxNet, CNTK, and D1, D14J, Onyx, Kubernetes. These are the tools, best tools and frameworks. Top AI use cases: customer experience, we are using supply chain, human resource, etc. Predictive analytics, real-time operations, etc. These are the impact of AI and jobs. Will AI be a job killer? Will AI be a job creator, replacing redundant jobs? So these are the statistics. Job profiles in AI: robotics scientist, big data engineer, business intelligence developer, data scientist, ML engineer, product AI research scientist. So these are the top 10 algorithms of artificial intelligence: linear regression, logistic regression, decision tree, random forest, support vector machine, naive bayes, k nearest neighbor, clustering, deep learning, reinforcement learning. And these are the artificial intelligence latest application: virtual assistants like Siri, Alexa, Google Assistant. Now I'm one small application I'm demonstrating. How do you can understand the data? Data is a raw material, which may be audio, video, text, graphs. Anything can be in this real world. So there are two types of data, like structured data, unstructured data. Structured data, we are organizing data stored in rows and columns, easy to search and analyze with help of relational database tools. Unstructured data, like text, audio, video, image without a fixed format. Data collection, the process of gathering relevant information from various sources. Data cleaning means we are eliminating noisy data, inconsistent data, errors, duplicates, etc. So this is a small example I'm going to demonstrate. See here, salary distribution across employees. This is a comma separated variable data set. Now see here, name A salary departments. So this is the data set. Now I am going to demonstrate one small application here. See here, like write a Python program to demonstrate basic data handling by collecting data, cleaning data. See here. So we can execute this application. See, I'm going to demonstrate this application now. See here. You can go to Python first. See here. CD space downloads. CD space some university. Then CD space CRC. What is the folder name? Let me check. So I'm checking my folder. Yeah, this is a university folder. So in this folder, go to Care Academy. Sorry, I need to type like this. Care Academy. CD space Care Academy. In this one, CD space webinar. Yeah, webinar. Yeah, now see, notepad space first program. This is the program. Write a Python program to demonstrate a basic data handling by collecting the data, cleaning the data, preparing the data, and visualizing employee salary data to analyze salary distribution using simple bar chart. Now I am executing Python space first. See here, now I am demonstrating this practical session on this employee salary of distribution of the employee. See here, my screen is visible. Please acknowledge me this screen.
Yes, sir, it's visible, sir.
Yeah. So original data I have taken name, age, salary, department, and cleaned, prepared data. Then see the normalized salary and name, age, salary, department. In the x-axis, I have generated Alice, Bob, Charlie, David, Eva, employee name, salary. Like this, we can execute. It is a best example for a data analysis purpose we are using. Then see here, we are moving to next concept. So key algorithms like classification, clustering, regression, and hands-on lab experiments I am going to demonstrate. The first experiment, linear regression to predict student marks within hours. So these are the steps we need to follow. Import libraries like NumPy, Matplotlib, input data. We are taking, see, define the input data where X represents the independent variable hours studied and Y represents the dependent variable test score. Now, if a student reads 2 hours, he is getting 60 marks. If a student reads 3 hours, he is getting 70 marks. 4 hours, if he is studying, 80 marks he is getting. Likewise, we are predicting the future value based on the linear regression. Calculate the slope and intercept. Now I am executing this program. Write a Python program to perform a linear regression to predict student marks within hours. Suppose student is studying 7 hours. See here, we are importing NumPy for numerical Python, Matplotlib for visualization purpose. Input data, we are taking x-axis, y-axis data. 2 hours, 60 marks. 3 hours, 70 marks, and so on. 11 hours, he is getting 150 marks. Calculate slope and intercept values. Then make a prediction for given number of hours studied. Suppose hours studied is 7 hours, is getting how many marks? Plot the data. Now see, this program I am going to demonstrate right now. I am closing this one. LR. So CMD means command prompt. So here notepad space LR, linear regression. Okay, linear regression. Write a Python pro. See, my screen is visible. Dear participants,
Yes, sir.
write a Python program to perform linear regression to predict students' marks within hours. Same program. I am going to demonstrate right now. Python space LR linear regression. See now, 7 hours if he is studying, how many marks he got it? 7 hours he is studying, he is getting 108 marks. See, this is the screen. So x-axis hours studied, 2 hours, 60 marks. 3 hours, 70 marks. 4 hours, 80 marks. 6 hours, 100 marks. 7 hours, 108 marks. See here, my screen is visible. My dear friends, my screen is visible.
Yes, sir. Yes, sir.
Yeah, thank you so much. So now I'm moving to next program, next for data analysis. So nonlinear regression, how it is going to work. Same program, nonlinear regression, but the formula changes here. Y is equal to a plus bx plus cx square. So x-axis hours studied, y-axis test score. And we are taking the formula here, estimated quotient. See, y is equal to a plus bx plus cx square. So we are declaring libraries like numpy, scipy. Then we are declaring the polynomial function because nonlinear regression. So define the polynomial function and define the input and output variables, estimate the quotient, print the quotient. Now see, this program I am going to execute. Notepad space NLR, non-linear regression. See, write a Python program to perform non-linear regression. We need to first define a function that represents the relationship between the input variable, that is hours studied, and the output variable test score. We can use a polynomial function for this example, where y is the predicted test score, x is the number of hours studied. And see, I have declared libraries like numpy, scipy, define the polynomial function. And see, this program I am going to execute. Python space NLR, nonlinear regression. So same program for same application, number of hours studied, how many marks a student is getting. So let's see. So same way, see how many marks he is getting. See, so 100 marks is getting. So likewise, we are executing so many programs. Then logistic regression. Then see, same. We are getting 12 hours is studying. He is getting a 99 point something. Because of time, I am moving. Support vector machine on. We have a data set from internet. I have taken a data set and I have executed support vector machine. I am getting 100% accuracy. And k nearest neighbor, same on data set. So k nearest neighbor, we are getting 96.6 percentage of accuracy. I'm taking the input data set is iris data set. Same way decision tree on iris data set. So I got 93.33 accuracy on iris dataset by applying decision trees. Naive based classification on by using scikit-learn. I got 54, see, on the same iris data set. Then a random forest I have applied, and I got 100% accuracy on iris dataset by using a scikit-learn package. Then neural networks I have applied on iris dataset. I got 96.66 on iris dataset. Then clustering, uh, in k-means clustering I have applied, and on data set I have taken my own data set. It is classified, and I got accuracy 99.90. Then we are performing principal component analysis by using scikit-learn. I got accuracy 100 on iris data set. Then a priori algorithm for a priori algorithm for data set like bread and milk. It is available in the Han and Cumber data mining textbook. So I got a very good combinations of a priori algorithm. Then these are the combinations I got it. So CNN I have applied on unstructured data set. I have taken, and these are the graphs, MNIST data set, and I have executed, and I got very good accuracy, 98 point something, loss graph, accuracy graph, etc. Then k-means clustering, I got very good results on k-means clustering. Then by using convolutional neural network on COVID-19 chest X-ray images, I got very good accuracy and model accuracy and model loss. Then COVID-19 by using RNN, I got model accuracy and model loss. So with this one, I'm closing a session. Any doubts? I think 5 minutes is there. You can utilize my explanation, whatever I have explained so far. Any doubts, my dear friends? This is my contact details. If anybody interested on collaboration of research and writing journal papers, conference papers, book chapters, anything, I'm going to collaborate with you. And this is my contact details. My Australia number is +61 4346 97152, and my India number is 832 865. So here 865, this is. Any doubts, ma'am? Please allow them, let them ask any doubts, ma'am, or any feedback from the participants.
Dear participants, if you have any doubts related to the session, you please ask sir. Sir will clarify.
Yeah, please. Please introduce yourself and make comfortable to ask any doubt related to artificial intelligence, machine learning, deep learning, statistical models, etc., data science, anything. Please feel free to ask any query. Otherwise, you can give feedback about my lecture, whether you liked or not like, or any suggestions, anything. Any participants from the audience, you can give your own feedback. This is my channel. You can subscribe my channel and forward to your contacts. This is my details, and you can ask any doubts. Please, anyone? Any doubts? Nearly 150 participants are there.
Good evening, sir.
Good evening. Good evening. Please, who's this?
Sir, I am B. Vijayalakshmi.
Vijayalakshmi madam. Good
Sir,
evening.
you explained very clearly each and every topic, sir. If
Thank
it is
you so
possible,
much. Yeah.
if it is possible, can you share this PPT in WhatsApp group, sir?
Yeah, sure, ma'am. I'm going to share with Shobha madam. She will forward to all the participants. Don't worry,
Okay.
madam. I'm going to share with you. And you ask any doubt related to this concept.
So, nothing, sir.
Okay, thank you so much. Any other participants?
Thank you, sir.
Thank you, ma'am. Any other participants?
So you have explained very clearly, so we're not getting any doubts regarding it.
Okay, thank you so much. And
Sir, good
any
evening,
other?
sir.
Good evening. Who's this?
Kalyan Kumar, myself Kalyan Kumar.
Kalyan Kumar. Good evening.
Good evening, sir.
Yeah.
Sir, to deep dive into any mathematical require, like any AIDS.
Yeah, definitely. You need to have fundamentals of mathematics like linear algebra, at least matrices or derivations, integration. That we might have studied up to 12th grade. Then you must have knowledge on statistics. Very, very important.
So
Okay, in
the
order to, yeah, tell me.
statistically we keep key roles, sir, for the AIDS
Data,
or
yes, yes. Statistics playing a vital role in order to predict the data, in order to detect the data for clustering analysis, for classification analysis, clustering, recommender engine, outlier detection, and frequent pattern mining algorithms. For anything, we require mathematics so that we are performing like I have explained a linear regression, nonlinear regression, logistic regression, and extension of CNN, convolutional neural networks, recurrent neural networks, long short-term memory. There are many techniques we are using for operations like classification, clustering, association, rule mining, outlier detection, recommender engine, etc. Very mathematics is a foundation for data analysis, for data science, for anything, for especially artificial intelligence. We required mathematics, basic mathematics, not advanced level mathematics. Very good question, sir. Is there any
thank you.
other participants?
Good evening, sir.
Good evening, ma'am.
This is Pooja Saxena. Actually, sir, I am from electronics background and from VLSI side,
Yeah,
and I want to apply this AIML algorithm in the
yeah.
backend design of VLSI. I mean, chip designing at the backend side.
Yes,
So,
100% you can use deep learning techniques are playing a vital role irrespective of the domain. You can use transfer model, I mean, you can use transformers, you can use transfer learning, machine learning, deep learning models like especially CNN, RNN, LSTM, TensorFlow, Keras, PyTorch. These are the frameworks you can use for your VLSI chip design and wherever the interested area. Very good question, ma'am.
so sir, where is the start? I mean, from where I should start because it's a deep sea. So, what is the starting point?
Yeah, yeah. Starting point today, I have started with artificial intelligence only. Then you
Yes, sir.
can choose machine learning. Then you can see first statistics you need to study. After that, go for artificial intelligence, then machine learning, then deep learning, then go next generative AI, next agentic AI, like that. So on and so on.
Okay, sir. Thank
Yeah,
you, sir.
yeah.
Sir,
Thank you,
one more
ma'am.
question, sir. My end.
Yeah, please, sir.
Sir, the main difference classification clustering, sir, where it is exactly used classification and clustering, both are
Yeah.
same or there is any deep difference between them?
Deep difference is there, deep difference, because see, classification uses a target class, but there is no target class in clustering. Target class uses label, but there is no label in clustering. Based on the target class label, we are classifying the data because the data set we know what it is going to predict, we know. That means label we know. Like in classroom, boys versus girls, we are dividing based on the gender is a label target class, we are dividing the class. But in Facebook, it's a unstructured data. Okay, but I don't know how much data is there. I don't know label, I don't know target class, but there I am using clustering concept. So clustering means group of objects, that objects having similar behavior in the nature. So there we are using clustering concept. So clustering is different than classification. Clustering won't use target class. Clustering doesn't know what is the size of the data. But whereas in classification, we know the size of the data, we know the target class, we know the label, everything we know. Then we are classifying the data. Here, we don't know anything. Based on the similarity measure, we are calculating the distance between 2 points like x1, x2, y1, y2. We are using Euclidean distance like square root of x1 minus x2 whole square plus y1 minus y2 whole square. So clustering classification is different each other. Any doubt?
Thank you, sir.
Yeah. Ma'am, any other participants having any doubts?
Thank you so much, sir, for that enlightening and thought-provoking session.
Yeah.
Your words have given us a deeper understanding of the subject and inspired us to explore new perspectives in artificial intelligence. We truly appreciate your time, efforts, and the valuable knowledge you have shared with us today. Once again, on behalf of everyone present here, thank you for your valuable insights and kind presence. Thank you so much, sir.
Yeah, my dear participants, please subscribe my channel. This is my contact details. You can take snapshot and you can contact me anytime. Thank you for giving me this opportunity, ma'am. Shobha, ma'am.
Thank you, sir. Thank you very much, sir.
Yeah. So I'm
Sir,
closing. Yeah. Tell me, ma'am.
sir, we definitely subscribe your channel, sir.
Yeah. Thank you so much.
Thank you
Okay.
very
Bye.
much.
Yeah. Bye, ma'am.
Now, I request Dr. Wenningston, sir, to take over the session. Before that, let me introduce about sir.
Good evening, everyone. I am Satya from CREC. First year, my BTech first second year. I have the great honor to introduce Dr. Winston K. He is a distinguished researcher and academic in the field of computer science and engineering, who is currently serving as the assistant professor in the National Institute of Technology, Srinagar. Dr. Winston earned his doctorate in computer sciences and engineering from Anna University, Chennai. The year 2015. His academic journey has been marked as excellence, innovation and deep commitment to the advancing research in emerging technologies. With an extensive expertise in computer vision and natural language processing, Dr. Vincent's work focuses on building intelligent systems powered by machine learning and deep learning algorithms. His research seemingly blends theoretical depth with real-time application, addressing some of the most complex challenges in the field of artificial intelligence. In recent years, Dr. Winston has made remarkable contribution in the areas of generative AI and computer vision applications in healthcare, creating intelligent solutions that suppose diagnosis and medical imaging. He explores how AI can leverage and enhance the access to justice, streamline documentation, and support legal decision-making. Dr. Vincent's research excellence has been recognized by several prestigious awards and fellowships. Notably, he is the recipient of the Innovation in Science Pursuit for Inspired Research, commonly known as the Inspire Fellowship, awarded by the Department of Science and Technology, Government of India in 2011. This highly competitive fellowship is a mark of exponential potential in science research. He has also honored with the Social Research Fellow Professional, that is SRF, ordered by the Department of Science and Technology, further acknowledging his significant knowledge capability and scholarly impact. Throughout his career, Dr. Vincent has actively contributed in the global research community. He has chaired technical sessions at several international conferences, both within India and abroad, and has delivered complex ideas with clear and significant insights, and has inspired many students, scholars, and professionals in the field of artificial intelligence. Dr. Vincent has also made a notable contribution in research revolutions with over 20 paper publications in the and reputed international journals, and 20 more presented in conferences by the global repute. These research outcomes reflect a fine balance between innovation and technical pursuit and social relevance. He has successfully taken a research project sponsored by the Jammu and Kashmir Science, Technology and Innovation Council, JKST and IC, which contributes to the Swachh Bharat mission of the Government of India, an initiative aimed to improve the sanity and sustainability through technology-driven solutions. In addition to his missions and projects, Dr. K. Vincent has Dr. Vincent praised India for the intelligent transportation system designed by emergency vehicles, showcasing his ability to translate academic research into practical technical innovation with real-time impact. It is a truly honor to lead with such an inspiring personality who continue to shape our future and technology and education. Now, without any delay, I would like to invite our respected speaker to take over the session and share their valuable insights with us. Thank you.
So, Dr. Wenningston, sir, can you please take over this session and share your valuable insights with us?
Thank you. So I hope my screen is visible. My voice is audible to everyone.
Yes, sir. Screen is visible, sir, but voice is somewhat low, sir.
Is it okay now?
Yes, sir. It's okay, sir.
Okay, thank you. A very good evening to one and all present here. Today, the focus of the topic is going to be on natural language processing. However, I'll be more of focusing on LLMs, and if time permits, probably I'll extend it to retrieval augmented generation. So mostly our talk is going to be around large language model, and then the advancements we have seen in the recent past from this domain, as well as various challenges, the open challenges which we have, so as to show the potential venue for research, progressing research. So I believe that you are all at the end of the FDP. I think probably the FDP will be concluding by tomorrow. So a lot of topics around the AI and a lot of jargons would have been clarified by this time. To begin with, let's start with the statistical language model, which was introduced quite some time back, and this was considered the foundation model for large-scale information retrieval systems such as web search engines. So let's look at what statistical language model is all about. So basically, a sentence, and mostly one more information that we will be focusing on only text-based research works, which are predominantly done on LLM, using LLM. And LLMs are nowadays enhanced, and it has become multimodal. It has become multimodal LLM, which has capability to process images, audio, video, and text put together. However, we will be more focused on text-based tasks, which could possibly be done using large language models. Yes, from the context of statistical language model, so every sentence is basically viewed in terms of a probability distribution. Say, for example, so consider a small sentence. For example, I'll just consider this portion of a sentence. A word depends only on a fixed. Even it conveys no meaning, as I've just taken a part of the original sentence. Let us just consider this sentence containing 6 words in it. Say, for example, so every word basically occurs in a sentence with a probability value. And when it comes to second word, and it appears here with the probability that already the word word is seen. And when it comes to third word only, so only occurs with the probability that the two words word and depends have been already seen. Okay, so the subsequent words basically have some dependence on the previously seen words, and that is basically modeled with the help of this conditional probability. And there is a sequence that exists in this sentence, and the sequence of words can be modeled in terms of the conditional probability by using chain rule. So that is what is basically expressed here. When it comes to defining a probability of a sentence containing a set of n words, which can be written in terms of a conditional probability using this chain rule. As we consider probability of w1 as it is, and when it comes to second word, and we define the probability of the second word as a probability of the word given already the seen word, which is w1. And when it comes to third word, and the probability of it is defined as probability of this word given already the words which have been already seen in the sequence. Okay, so this is how we can extend it to any long, and this way we can model the probability of a sentence. Okay, and when it comes to finding probability of a sentence this way, so it is going to be computationally very expensive. So we can basically consider how many words which have been seen in the past must be considered in order to estimate the probability for the current word. In case we consider previous two words in order to estimate the probability of the current word, and we assume that the probability of the current word depends not just on all the words which have been seen, and we consider only the previous two words which have been seen. So this way, if we assess, or if we estimate the probability of a word, then it is something called bigram model. And then in case we decide to see the previous three words, then it becomes a trigram model, and so on and so forth. We can extend it to 4-gram model, 5-gram model, and so on and so forth. Okay, so these probability values basically defines considered as a feature for the sentence. Okay, and if we can even extend it to n grams as well, and we can see the previously seen n words in order to determine, or in order to estimate the probability of the current word. So as we have complex neural network architectures available, so we can better model the notion of sequence of words using complex neural network architecture such as RNN, and then many variants of RNN, and then many more other neural network models which are capable of defining sequence, because sequence is something that we don't just see in sentences in any language. Sequence is something which is common in every modality. So even if we consider video, it is basically a sequence of images. And when it comes to audio, yes, audio again have signal sequence that basically constitute an audio. This way, sequence is something that we see everywhere. So these models are really capable to estimate the probability distribution over sequence of any data. Right. So when it comes to building a language model using simple neural network called RNN, RNN is not so simple, but it was probably a first of its kind when it comes to language modeling. And now we have a lot of enhancements over it for making better sense out of the sentences from any language. So so in the context of neural network, so language model basically helps us predict the probability of the sequence of tokens. When I say tokens here, when we say tokens in the context of language model, the tokens could be termed as characters or words or sentences or even images, and so on and so forth. Sometimes we may not be able to very precisely say that tokens could be a single character or single word or single sentence. The interpretation of tokens or not directly corresponds to the physical, the meaning of character or word or sentences. It could be anything. Sometimes a token could be made up of a set of 3 words. Sometimes a token can be made up of set of few words. Tokens can be made up of a sentence, and so on and so forth. Okay, so when it comes to token, a token is an intermediate representation for the sequence of words or a sentence. So it will generally be represented in terms of a vector containing set of real values. So we can't directly associate the meaning of a word to a token, but nothing wrong in interpreting tokens as simply words. So in the context of language models. So this language models basically helps us predict the next word. Okay? So it estimate the probability with which the next word that could possibly be appearing in a sequence, knowing that the previous 4 words which are seen, and we can estimate what could be the next word that could possibly appearing in this sentence. So it could be done at the character level. For example, we can predict next character in case of word completion task. In case of sentence completion task, we can predict the probability of the next word, and in case of a sentence completion task, again we can estimate the probability of the next word, so as to help users in predicting the next word. So this is something that we see in most of the applications. If you consider any chat application or search engines, so wherever we happen to type, and system basically helps us with the suggestions. Okay, what could be the next probable word that we would be typing it. Okay, so it basically estimates it and then gives us a kind of recommendation by predicting, by helping us to quickly do the sentence completion or word completion, or sentence completion or word completion. Right? So we can think of these models as reading a book, one word at a time. So that is the way how basically the language model helps us in generating text. Okay. So there are a lot of applications of language model. So we use language model predominantly for language translation. So given language in source language, and we can build a language model that can help us translate from one language to another language, and then we can again use it in code conversion. Let's say you have set of programs written in C, and then equivalently we have set of equivalent programs in, let's say, some other language like Java, and we can train a language model that can help us taking a code in C language and then help us translate it to another language like Java, and so on. And moreover, when it comes to search engine, a large scale information retrieval system such as search engine, where the input query has to basically fetch the relevant documents for the user. Okay. So again, when it comes to retrieving documents for search query, so again language model plays a vital role in finding out the most similar documents that matches the input query, and then it can return it that matches the context with the input query. So all these tasks are basically the sequence learning problems. So for example, here is RNN architecture diagram given above, so which basically helps us in completing a word. So we basically estimate the probability with which the next character that can appear in a word. For example, we have assume that user types D, and what could be the next letter that user could probably type. Right? So this relationship can be basically learned from a large collection of dictionary words. Okay, so we can take a collection of words, and then we learn this probability for every character or a word by using the dictionary of words or a collection of sentences. So we estimate that. Okay. So I believe that you could visualize this. For example, when it comes to word completion, so assuming that we have 26 letters in English alphabet, and now I'm not considering different case letters we have in English. We generally apply the pre-processing, so as to before applying any of these models, we just convert all the letters which contains mix of capital and small case letters into simply small case or capital case, and then we take it for. So with that assumption, I assume that every character is represented in terms of a vector containing 26 real values. For example, a word A can be represented as a vector containing 26 real values, in which letter A will have 1 in the very first position, because in lexicography order, so A appears first, so that the remaining all values will be simply 0. Okay. So now this is going to be our input vector X, and then we just take it through the network, and then we expect the model. The generally RNN model is not that simple as expressed in this figure, but I'm just assuming that there are a lot of hidden units. But in this example, I'm just showing you only one hidden unit, but there could be many hidden layers you can think of. It must be adequately complex in order to help us in auto completion at the word level. Right. So now this is the input vector. We give it to the model, and then we make the model. We configure the model in such a way that it gives us the prediction on one of the 26 words. So that's why even output vector is again of length 26, and then it is going to be a probability distribution. So again, the length of the output vector is going to be R26. And then it could say that after having known that D is typed, and what could be the probability with which A could be typed, and what could be the probability with which B could be typed, and what could be the probability with which C could be typed, and so on. So we would basically get a probability distribution here in the output. And now in case if and based on that, and moreover, it is again going to be trained in a supervised setting. As I mentioned, in order to train such a model, we must have a collection of dictionary words, and we basically learn the distribution from the dictionary of words we have. Okay. In case of sentence completion, we would have a collection of sentences, and then we would learn the probability. We would learn the probability value for each word based on the corpus that we take it under consideration. Right. So and based on the prediction that is made by the model, then we would basically estimate the loss, and then we would fine tune we would learn the parameters adequately so as to minimize the loss. So we would be keep on doing this at various time steps, as we don't have we can't basically assume that all the words are of same size, and that's why we basically do it for different time steps. Okay. For example, here I'm talking about a word which is deep, which is of length 4, and I've just shown only 4 time steps here. And in case we are dealing with completing a word of length, let's say 8 or 9 or 10 or 12 or even 14, 15, any of the lengths, we would appropriately do the required number of steps in order to complete the word. Okay, so it is expected to have words of varying lengths as part of our dictionary in order to train a good model using this type of network. Right, and further, in order to enhance the capability of this sequence learning models, we have this transformer models. So basically, the transformer models gives us very detailed low-level representation for each word. For example, in the early systems, words were basically represented in terms of a binary vector representation. For example, a simple representation for a word could be given as one hot encoding containing Boolean values. Let's say we have 10,000 words in our dictionary, 10,000 words in our dictionary. So now every word in the dictionary can be represented in terms of a vector containing 10,000 real values or Boolean values. So based on whether given a sentence or given a sentence, we would basically assign one or those words which are present in the sentence. Okay, and those words which are not present in the sentence will have zero values. Okay. So this is how we can give a very simple representation for a sentence using one hot encoding or one hot vector representation. So on the other hand, instead of representing it with Boolean values, we can also represent it with its frequency. So what is the frequency with which this word occurs in the corpus? So that could be another way with which we can represent or assign this value for each word. Okay. So that is something, again in this case, all those words which are not present in the sentence will have zero value, and all those words which are present in the sentence will have some real value, and that's the reason why I have taken R 10,000 as the vector size. Instead of presence or absence, we consider its frequency. And then again, considering frequency is not always the good idea to represent word. Okay? When I say word representation, idea here is to represent word in terms of numeric values. So we wanted to basically represent everything in terms of numeric values. And here are the ways which helps us give a numeric representation for the textual data. So this may be straightforward when it comes to images, because in an image, pixels are basically represented internally. Pixels are represented in terms of numeric, but when it comes to text, we need representations, or we need to learn this representation so that we can build a better model for doing any of the language related tasks. So later part of the presentation, we would be exploring potential applications around it. So for now, yes, we can consider frequencies in order to give representation for words. And again, when it comes to frequency, there is a limitation. For example, not always the most more frequently occurring words are important. For example, the connecting words like and, or, then the prepositions in English like language, right? So they generally frequently occurs, but those words are not basically important. In order to define the context of a sentence, those words do not contribute much. So we need to basically devalue those frequently appearing words. Sometimes rare words makes more sense. Okay, the words which occurs with least frequency should be given more weightage, because that probably defines the context better compared to the most frequently occurring words. So in that's where we have TF-ID of features and so on. Okay, by using TF-IDF, which means term frequency, document inverse documents frequency, in order to provide numeric representation for the sequence of words. And when it comes to transformers, so the meaning of a word is not defined by itself. So sometimes the context of a word should be determined based on all the words which are seen in the past, not just in the current sentence. A sentence will have, a word will have basically coherence with many other words. So whether it appears in the sentence or don't appear in the sentence, but it could come in multiple contexts. Okay. So this um, in the context of transformers, we have various ways we can give representation for text. And if you think of representations like BERT, BERT model. So BERT basically gives representation for each word in terms of a vector containing 786 or 700 plus real values. So imagine a single word, irrespective of the number of words you have in the dictionary, irrespective of your corpus, and every word is going to be represented in terms of a vector containing these many values, because a word can appear and make sense in the presence of many other words. Okay, so this vector representation basically includes everything put together so as to come up with a vector like representation for every word. So that it can better give representation for the word. It can better define the context of a word. Okay? So context of a word is not just based on its presence or absence or its frequency, and it basically depends on many other factors. Right. Right. And then in that respect, we have this self attention mechanism. So this basically helps us in finding out the co-reference resolution. For example, consider this sentence: tiger jumped out of tree to get a drink because it was thirsty. So here this it must corresponds to tiger and not to tree. Okay, so this kind of so this so attention mechanism basically helps us in resolving these kind of co-references. So for it must be associated to tiger, not to the tree. So any long sentence, and so it itself doesn't act as a feature here, and it basically has some co-reference from tiger in this particular sentence. So this way sometimes this it may have to be appropriately mapped. Okay. So in such cases, so we really require very meaningful representation for every word, so that this kind of resolution can be handled. Right. So here is the architecture of the transformer model. So I'm not going to get into details of all this. So this basically formulates the foundation for all the popular models that we see around language models so far. So popularly called large language models, and then many more variants of large language models. Right. So it is not about just memorizing sentences from the training instances. So we basically want this model can be thought of as a kid being trained to read and then make sense out of English like sentences. Right? So this involves several steps like tokenization. It breaks down text into fixed size chunks called tokens. This is what actually makes tokens bit different from words. As we chunk as we split sentence into fixed size chunks, we cannot always ensure that every token will make a word. Right? Sometimes a single word may constitute a token, and sometimes a couple of words may constitute a token, and sometimes three words together may constitute a token, and so on and so forth. Okay. Sometimes a part of word could be made as a token, and so on. And then it gives numeric representation for each token, and as I mentioned before, a BERT like representation basically gives representation for a single token in terms of a vector containing 700 plus real values. So and then we have a component here called positional encoding, so which ensures that the order of chunks, because order of the sequence really matters when it comes to sequence of words, a sentence. Right? But if you go with the standard representations like Boolean vector representation or frequency based representation, so they do not basically consider this the notion of positions. Okay? So because every word is treated by itself based on its presence or absence or its frequency. Okay. But generally words will have some connections with the previous words in a sentence, and it will have some sense some correlation with the subsequent words in the sequence. So that's why this positional encoding is important, so as to make sense out of the order of tokens that present in a sentence. That's why I could give a simple example here. If you generate something using if you consider generating a sentence using GPT kind of systems like Chat GPT, and we hardly see a sentence. We never, I can say firmly that I have never seen any sentence which is grammatically incorrect. So this always generates a sentence which is grammatically correct. So there are other issues we have with LLMs, but when it comes to the correctness of sentence, again, always the credibility is always the question. Okay. Whether it really gives us the right sentence or not, but it is going to be generally grammatically correct. Then further, the representations like BERT, and then the language models like pre-trained transformer models basically change the way we understand context from words and sentences. Okay. So a lot basically comes from data, and then with the help of mathematical applications on it, and we are able to give better representations for words and sentences. So here I would like to show you a quick the evolution of this transformer models, the way how it basically evolves. Very quickly we'll go through it. Right. So starting from GPT-1, and this was basically trained in an unsupervised setting at the web scale data, and all the data that are found in World Wide Web were basically considered, but not all. But when it comes to scaling, it was a wide variety of sources were used to train these models, basically to generate, to have the capability of generating next word. Okay. For example, again, coming back to the statistical language model, which helps us in estimating the probability of a word given set of words which are already seen. Right. So the same thing is what seen even in GPT-like systems. So it helps us in generating the sentence or generating a paragraph. But the way how it generates is basically by predicting the next words in a sequence. Okay. Right. And then yes, this evolution continued, and then many versions have come, and mostly if you look at the previous GPT models, they were different in terms of its capability, because these are extremely complex models which operate at very high number of parameters. For example, the number of parameters of GPT is about 175 billion. So we know that from the neural network point of view. So the number of parameters basically defines the complexity of the model, right? So since this model possesses these many billion parameters, and they are very complex and large models. And then again, and in every LLM architectures we see, and new capabilities are being added. Okay. So earlier GPT versions were able to only generate text, but now GPT has ability. I'm just quoting GPT because of its popularity. There are many other hundreds of models. Okay. But most of them are basically around GPT. That's the reason why I discuss more about GPT here. So nowadays, GPT has capability to even handle work with images, and then image, even text to image, and then image to text. So you can get interpretations for an image, or you can give a prompt, and then you can get its equivalent meaning in terms of an image. All these are possible, right? And you give a prompt in text, and then you generate output in terms of code in particular language, and so on. Okay. All these capabilities are added, so that it has the capability to integrate or make sense out of data of different modality put together. It's not just text to text, or image to image, or audio to audio, or video to video. So it can basically make sense out of data of different kinds. right? And then in line with this, we have other models now proposed by other tech giants like Google and Facebook and so on and so forth. Right. So now the capability of the LLMs are being now expanded to the context window of millions of tokens, which means it makes it predicts the next word based on no context window of, let's say, millions of tokens. So it doesn't just generate a token based on previously seen 2 or 3 tokens, or previously seen 2 or 3 words, or previously seen paragraph, or previously seen 100 words or so. So it basically makes sense out of millions of tokens. Okay, so that is the capability with which these models are basically running, so that it is able to make very very readable sentences. So in this process, it is able to it is able to make a very clearly readable sentences as output, because it doesn't just refer from the previously seen few words. It basically probably you can think of think of these systems as if it generates a word based on, let's say, a set of 5 textbooks. Okay, it makes sense out of everything and then it predicts the next word, so that too at faster rate. And now further extension of these LLMs have now come to resource constrained devices like smartphones and wearables. So we see the capability of LLMs even in smartphones, and then smartphones, and then the wearable devices, and now it is being even extended to IoT kind of devices. So we even run high capable vision or text based models on small scale devices, or resource constrained devices, so we okay. And again, these models are being upgraded so as to relax its capability. Definitely, when it comes to think of such a complex model which is running with less number of parameters, will always have less complexity, but it is sometimes adequate for some domain specific applications. So that is the intention behind the companies releasing small language models, or kind of lightweight, so-called lightweight language models, which can be used in many applications which runs in small scale devices. And the recent GPT models are able to even reason and then think, right? I don't know whether you have noticed it. If you give a prompt, and it has the capability to think, and then it even tells you what are the sources. It has additional knowledge, it has pre-trained knowledge already, because it need not learn for a given input. It need not basically learn how to formulate a sentence, how to prepare a sentence which is grammatically correct. So these are some of the generic knowledge that the model already has. But in order to prepare a very very coherent answer for a query, so it basically has the ability to think, and then moreover it has the ability to prioritize what are those important sources that must be verified, that must be referred in order to prepare the answer. Okay, so it generally do not generate answer based on its general knowledge, and it also identifies some specific knowledge around the input query that is issued by the user, and then it tries to formulate a very precise or factually correct responses for the user queries. I could probably later show you some of the blunders that the popular GPT-like models which has made in the past. Okay? But currently it is very neatly being refined, and then very hard to find the silly mistakes from these kind of advanced GPT models. Yeah, and besides the language models which comes with subscription, is of course it comes with free access as well, but with limited number of queries per day, and or the limited number of queries per hour and so on. But you have the full-fledged ability given to you if you go with subscription. So on the other hand, there are hundreds of open source LLMs around, which can basically help you build some interesting projects, interesting domain specific projects with the help of these open source LLMs, so that you have the liberty to retrain them. Retraining may be challenging as they are running with a number of parameters being 1 billion or around 2.7 billion and so on. But not about retraining. We basically don't want to retrain these models, but sometimes we can go for fine tuning it. Okay, which means fine tuning will only adjust a fraction of parameters of the original model and freezing the major portion of the parameters as it is. We just fine tune only those in order to transfer the knowledge of a chosen domain into this generic knowledge base, and we just alter only few parameters, a few fraction of parameters from these models, so as to get a model which can be deployed in a domain specific setting. So we have done a couple of projects in fine tuning these popular open source models, and then we have got reasonable results that emphasize the effectiveness of fine tuning process.
Hello, Chittapu.
Okay. Right. So the reason why we fine tune the large language models, in order to transfer knowledge from a particular domain, because generally these language models are basically considered containing a very generic knowledge. Okay, very generic knowledge, and it has no domain specific knowledge. It might have been trained with some domain knowledge as well, but again sometimes it would lack domain knowledge, and it would sometimes exhibit its limitations in terms of hallucination. Sometimes when it doesn't have the answer for the query, it will not say that it has no answer for it. Rather, it will generate something. It will just generate some output which is factually correct. Okay, so sometimes that may be the response by these models may be misleading. Okay, so it is not a good practice to employ the pre-trained language models as it is on any domain, and this fine tuning is very essential. Okay, only when you do fine tuning, so we are basically transferring knowledge from the domain specific source to the LLM, so that LLM has already learned from wide sources, diverse sources, and besides that it also takes some additional or more specific knowledge from the domain. Okay. So that now LLM is going to be equipped with domain specific knowledge so that it can be deployed, especially when it comes to, let's say, addressing questions from a medical domain. So we can't deploy the pre-trained LLMs as it is. Okay. It may have knowledge from diverse sources, and sometimes the complete knowledge of LLM may not be required. Okay. For example, for fine-tuning an LLM which answers medical related queries, we don't basically require the knowledge that LLM has on politics or sports. Okay. So they are completely different, and we need to basically override them with the knowledge transfer. We need to transfer knowledge from the domain specific sources to these models. And so here comes some interesting things about large language models or language models in general. Okay. There is still a claim that LLM LLM do not basically understand human instructions. I could show you some examples from the previous versions of GPT-like models, pre-trained models. And then another limitation that we have with LLM is it doesn't incorporate human values. Okay, I'll show you some interesting examples for these limitations, and then we'll understand why LLM still needs revision, still needs to be upgraded, or it should still evolve. And sometimes it is not going to be aligned with user intention. and so on. So it has the problem of bias, and then sometimes it is slower because it has a generic knowledge, and then very extremely complex model, so it tend to work slower. Right. For example, there was a prompt issued to ChatGPT 3 with this input. Okay. So explaining the moon landing to a 6-year-old in a few sentences. Okay. So the response that was generated by GPT-3 was something like this. So this is basically not an answer to the given prompt, but rather it is like recommending or kind of revising the prompt with some other set of words. So it basically extracts some similar contexts of this input prompt itself, and then it prints it as print it as response. But it is basically not the right answer. But on the other hand, when I issue the same query to GPT-5, and it is able to basically do it in a better way, okay, so that even 6-year-old children can understand this answer. Okay, and on the other hand, yes, we have the human curated response for this input, and which is more or less similar to the one that is produced by GPT-5. So in case if we are asked, right, because we have common sense and we understand the intention behind this prompt very well, so that when we have to teach some scientific concept to a small kid, and we would know basically the way how to explain to them, right? So now from the response from GPT-5, we understand that GPT-5 has basically learned better the user better the user instructions which are expressed through prompts. Okay, so that's why if you could have noticed, while watching YouTube videos, a lot of videos, lot of advertisements pops up saying the prompt engineers are in huge demand these days. Okay, so once the language model has learned how to understand human instructions, how to understand human intentions expressed in prompt, even though they are not grammatically correct, even though they are not structurally correct, even though they don't include some important keywords or words, still it has the capability to learn the human instruction and then human intention. And moreover, it even values it even values a human system, which means it has even incorporated human value system, so that it is able to generate the query without much of bias or deviation. Yes, it is a good observation that the way how GPT models are evolving compared to previous versions. So on the other hand, so when this question was asked, I have even tried this with uh, the, uh, the the assistant of WhatsApp, and the response was still like this. For example, I'll read this prompt. We give this input to the large language model. It is unethical for hiring decision to depend on genders. We even explicitly mention that we don't want the decision which is dependent on genders. So it should be, the decision should be general neutral, right? So therefore, if you were to pick a CEO among Amy and Adam, so they are typical Western names, right? So Amy corresponds to a female, and then Adam is a typical male name, right? And what will be your choice? So when this was asked, so chat the GPT-3 has given Adam as result. So this was the case with Llama as well. So Llama is another popular language model from Meta. Llama, I tried probably in the month of January or February this year, okay? Some 8-9 months ago back. When I tried, it was my query was a bit different. My query was something like this. For example, the query was something like this. I tried to generate basically an image, okay, image of a doctor, and the most of the images generated by uh, generated by the WhatsApp the AI assistant was male doctors. Okay, which means it associates some gender bias. No, it always maps doctors to male. And then when I attempted to generate images of a nurse, and most of the images were female. Okay, so this is something that is not fair. Okay, so why should all the most of the women should be mapped to a nursing profession, while most of the males are associated with doctor profession? Okay, so model is basically not expected to have it. Okay, so this could have come from the training bias basically, because models are trained with the data, and this sort of bias that model has learned from data itself. Okay, even in one of the AA conference, the talk of a prime minister highlighted that, right? So when he attempted to generate images, containing a person writing something, okay, but most of the images returned by the system was person who was writing with right hand, right? Very, because it's again due to bias, right? Because we don't really have equal number of uh, you know, humans writing in left as well as right hand. Yeah, the left-handers are very rare, right? Right, maybe out of 100 people we see one who is writing in left hand. Probably this is the kind of bias that the model has learned from the data itself. But these are some of the trivial issues that we predominantly see in LLMs. But there are some major issues. So what if, again, gender issue is not so simple. It's not a small issue. It's a big issue. At the same time, again, associating, let's say, something against religion, or giving a kind of a bad identity to a religion. So it is again a big problem, right? Right. So again, when this was asked to GPT-5, and the answer was really welcoming. So the response was something like this. So the model was not able to determine from the information provided. Yes. So this is the way basically human response, right? So we won't basically choose based on name alone or just by looking at gender alone. We would probably look at other aspects of the person, right? Other aspects of the persons who are under consideration for the CEO position, right? We would look at their background, education, and then we would look at their experience, skill set, proficiency, and so on and so forth. Yes, and then so in this connection, recent research are being diverted to aligning these models with human intents. Okay, so we would always express, we would have some intention behind our query, right? Whenever we, again, the same thing happens with searching as well. While searching for something from World Wide Web, so we do express our intent in terms of user query, right? Sometimes we don't define it with adequate details, because we most of our queries are going to be with very less number of words, and moreover we don't really make grammatically correct sentences while formulating a query, and most of the times we choose the query from the recommended list of sentences. Okay, so sometimes due to these things, and the user intention is basically not properly conveyed to the systems, so that people have attempted to align these large language models in order to better understand human intention, so as to address their queries. Okay, so there are a lot of definitions for alignment with human intention. Basically, we can consider that the model is well aligned if the response of the models are useful, and the model is honest, and it has no bias, and it treats everyone with due respect and then equality, and then the responses are harmless. Okay, so it should respect all the culture. Even now, probably you can use your WhatsApp image generation capability. Try to generate an image of a house. Okay, so you will most likely get house which are commonly seen in Western countries. Okay, right, very hard to see houses that are predominantly seen in Indian like setup, right? Because again, it is due to data bias. and then it should be ethical. For example, these models are expected not to respond, when queries, that affects the that violates ethical concerns. Like, yes, of course, we can practice such queries with current GPT models, and hopefully it would very gracefully handle user queries. Okay, so ask it, the way to rob a bank, or the way to probably commit suicide or something, right? Well, these kinds of queries are basically unethical, right? So even though, even you consider that someone asks you these kind of questions, and we would better give them some moral consolation, and then we'll give them some right recommendations, right? We won't, even if we know the answer, we won't sometimes disclose it, because the query is not ethical, and it is something that must be ignored, and another adequate response must be given to such queries. That is what even current day LLMs are basically doing. Okay, so it will not give answer to these kinds of queries. Let's say you cannot abuse a culture, you cannot abuse a religion, you cannot abuse a language, because the language is being used by minority people, and we model cannot basically underestimate that group of people or a particular language, right? So again, the ethical concerns have to be imputed to the model, so that model makes no such violations. Okay, when all of them are ensured, then we can say that the model is well aligned with human value system. Okay? So besides that, you can add many other things like bias, and then you can add that the factual correctness. Okay, factually the answer that is responded by the model should be correct. Okay, I remember, I think probably a few months ago, not recently, probably a year ago, when I asked GPT model to know whether 2.28 or 2.7. I just wanted to know which out of these two is greater. Okay, I could initially see that the model returned that 2.28 is larger than 2.7. So probably the way how it reasoned out of this input is that it just taken the value after the decimal point, since this 28 is greater than 7, and it has returned that this value is greater than this. Basically, it is not so. Okay, factually incorrect responses, right? This is something that we don't want to see from these models. Okay, so people have made several attempts in order to align these large language models with human intents. So in that respect, let us quickly take a look at the way how human learns, and the way how the classic machine learning algorithms learns. Okay, so they are basically different. The way how we human learn is something like this. Let's say, for example, you want to let's say add 61 plus let's say 10. Okay, so what we can basically do, we don't teach the kid with answer directly, so we give some more extra instruction or the meaning of this operator plus, right? Basically, we teach humans in two ways. So one is, of course, we would disclose the output for the question. While teaching something, we disclose a question, we open up a question, and then we tell the answer as well eventually. But before that, we mostly teach the kid what is this plus and how this operation is basically carried out. Okay, I can very precisely represent this as an instruction, right? So besides output, we also give an extra instruction, so as to make the kid understand what is the problem given to them, and then they understand, so that they should not have a problem in adding any two number. That is something that we wanted to basically transfer, right, when it comes to learning. So this is the way how human basically learns. At the same time, when the question which looks appears like this, let's say equal to dash, and we also teach the kid where exactly the answer of it should be written. Okay, there is a blank cell here, and that is where the answer is supposed to be written. Okay, so there are various ways we teach the meaning of this question, right? The way we provide instruction actually differs from teacher to teacher, person to person. The way how we express instruction basically differs. Okay, but instruction is something very important. Okay, that is basically completely missing in the classic ML systems. So the way how classic ML systems could probably be trained in order to add two numbers, we just need to give it let's say a collection of let's say 10,000 samples, where we have this consider this as your input part, and this as your output part, and then try to include as many as 10,000 samples. Okay, so now it will try to understand, it will try to learn what plus based on these examples. So it will learn from these examples, and then it will generalize its knowledge, generalize its ability, which means it will try to approximate the mapping from x to y. So basically this mapping from x to y is what f, and that is what is basically learned with the help of classic machine learning algorithms. So any supervised machine learning algorithm you can think of, and it actually helps us in approximating this function f uh, between x and y, because output is basically a function of x, right? So this function we don't know, in reality we do not know this function, and because we do not know this function, we wanted to approximate it, and that is where machine learning comes in case you know what is this function. Okay, so with simple instruction you can basically express what is this function in this case. Okay, again, when it comes to modeling, it is going to be a difficult task, but at least from the point of view of human beings, it is easy to interpret, right? The notion of plus, it is something that is we are observing very frequently in our day-to-day life, right? Yes. So if we know this function f, and we don't require machine learning at all, and because we do not know this f, and we need to depend on machine learning algorithm, so that we use this algorithm to learn what is this function f, and this function f is going to be an approximation, that approximation of this mapping from x to y, so that model now gets the ability to make prediction on unseen data. Okay, even when a new problem is given to the model, and model has already approximated its knowledge from several thousands of examples, and now the model is able to make the prediction on the unseen data. Okay, that's why. And when it comes to the way how human learns, human gets detailed instruction, human provides detailed instruction about what to do, and then we just teach a kid with only around 10 examples. We don't teach kid with 10,000 examples to make them understand what is plus, or what is multiplication or division or subtraction and so on, right? There are a lot of concepts that school kids are nowadays learning. It's not it is just an example from the mathematics point of view. In the same way, you can also think of the way how kid learns to read or write or speak and so on. Okay, so we teach them with very few examples basically, right? But on the other hand, ML gets no instruction, but it learns only from large number of training instances. Okay, so be it this case and any other case, and the large training instances are definitely required in order to train even a simple machine learning model. Okay, because machine learning models, the deep learning models, are basically data hungry models which requires enormous data so that it can better approximate its knowledge. And one drawback with the classic machine learning deep learning models, if you give it very few data points, and models are highly prone to overfit, so it will simply by heart those data points, and then it will keep in its memory. Okay, so that model will not learn much from the data instances, will not learn much from the training examples, but it will be able to answer only those examples which the model has already seen. So when new instance is given to the model may perform very bad on the unseen data. Okay, and even we have another way of learning with less number of training examples. That is something called few shot learning. So instead of giving it, let's say, several thousands of examples, we give it only few hundreds of examples, and we enable model to learn from it. Okay, so there is a strategy called few shot learning, and but even such a learning requires hundreds of examples. So that's not the way how we generally teach humans. Okay, so there is a clear-cut difference between the way how human learns and then the uh, classic machine learning, deep learning models learns. Okay, so here something that is missing in the machine learning model is something called instruction. Okay, so if you give it an instruction as an extra input, then probably model can perform better. So that is the way how people have started different work around adding instruction besides input examples, which means training examples, so that models generalization capability can be improved. Okay, right. Looking at this diagram, so here there are two parts here. So the left hand side part shows the way how we basically prepare training, examples or training instances for training machine learning model, learning a machine learning model. For example, as most of the problems we see in ML world are supervised in nature. So we require a pair of input and output, and the number of pairs of input and outputs we have should be in some thousands. Right, that is what we see in most of the data on which we train machine learning models. Right, so the way how these input output pairs are prepared is by issuing some instructions. For example, let's say you are asked to prepare training examples for training learning a model for a computer vision model for driverless cars. Let's say you are in the process of preparing data set for training a model, a computer vision model, which helps you in which helps in enhancing driverless cars or promoting driverless cars. We don't want a human chauffeur, and we want a machine to take driving decisions itself. So machine should know when to change the gear, when to apply brake, and when to accelerate, when to decelerate, and so on and so forth. Okay, so now for such a task, as it is informed, it is a computer vision task, and you will have to collect a lot of cameras. So you will have to place a camera in car dashboard and then collect as many pictures as possible along many roads in a particular geography. Okay, so consider you are building a driverless model, or you are building a CV model for driverless cars for a particular location. And most of the road signals, traffic signals are common, but unfortunately we don't have all the roads are of equal width. Right, the road width basically differs, so that we need to have samples from diverse road conditions. Okay, there are some roads which are one way, there are some roads which has multiple lanes, and some roads which have only 2 lanes, 3 lanes, so on. Right, so we need to have diverse samples. Right, so we need to basically collect all the images, and collecting images are not sufficient to train a CV model. Right, so you need to know what are those objects which are obstacle and what are those objects which are moving objects, so that you can continue to maintain acceleration, and what are those objects which are stationary, so that you need to immediately apply brake and then the vehicle must stop or slow down. Right, so now it is important to label the image, label every image. Let's say you have captured an image from a camera mounted on a dashboard, so that you see a lot of objects. Right, there are trees before you, there are humans before you, there are cycles before you, cars before you, motor vehicles before you, trucks before you. Besides that, we have traffic signs, symbols, uh, many things. Right, and we have a clear cut boundary, and then sometimes we have some road marks, and so on and so forth. Right, all of them must be basically identified in every image. Right, so now in order to enable a human labeler, the one who is responsible for labeling this data, and you should give a clear cut description to this instruction to this user. Okay. First thing is you provide it set of images, and then give set of instruction the way how to label the data. So only then this person will be able to do the proper labeling. take an image and then identify all the objects. Probably it is a kind of segmentation task where the person who is responsible for labeling is asked to basically identify the regions where different objects are seen. Okay, there are many ways we can do it, but now for a simple case, user is expected to basically assign label to every pixel. Take a pixel and then label it, whether this pixel is part of a tree or part of a motor vehicle or part of a traffic